Alright guys, today we are going to finish up the notes from lesson 9.6, starting with example 3, which is modeling real life. So the question says, you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend ran the play as shown, where each grid line represents 10 feet. Did your friend run the play correctly? Alright, so if we were looking at this, this is very similar to the ones we did yesterday, where we want to figure out, is this a right triangle? So in order to do that, I need to find D1, D2, and D3. Alright, so if we were finding D1, right, I know that D1 is a 30 by 30 triangle, right, so 30 squared plus 30 squared, so that would be 900 and 900, so that would be 1800, so D1 would be the square root of 1800. Alright, if we were looking at D2, D2 is 50 by 50. So that would give me 2500 and 2500, which would give me 5000. So D2 is the square root of 5000. Alright, and then D3, D3 we can see is a 20 by 80. Alright, 20 squared is 400, 80 squared is 6,400. Right, that would add to 6,800. So D3 is the square root of 6,800. Alright, so now we need to plug these into the Pythagorean theorem. I know that D1 and D2 are the legs, because those are the smaller numbers, and I know that D3 would be, I know that D3 would be the longest side, right, so I plug that in for C. Something squared in the square root would cancel out, so I get 1,800 plus 5,000 equals 6,800, which that would add to 6,800 equals 6,800. So yes, your friend ran the play correctly because that formed a right triangle, which is what we were trying to decide. Alright, feel free to pause the video here to try the self-assessment ones on your own, or keep watching. Alright, so for number 9, it said you practice archery as shown, determine whether the arrow is perpendicular to the vertical support, justify your answer. So here we need to know that the word perpendicular, right, means a 90-degree angle. So is this a right triangle? So to decide if it's a right triangle, right, I'm just going to plug in my sides, which are 7 and 14, and then my longest side is 16, so 49 plus 196 equals 256, and that would add to 245 equals 256, which is not true, so no, it is not perpendicular. Alright, and then last one here. 10 is a little tricky because here we need to find a coordinate, right? So it says 3 fire hydrants in a neighborhood are represented on a map. The coordinates of the fire hydrants are 0, 0, 2, 5, and 7y. The fire hydrants are arranged in a right triangle where y is a natural number less than 10. Find y. Alright, so we know that it is a right triangle, we know that y is a natural number less than 10, okay, which means that it is going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, because those are our counting numbers. All right, so let's set up this problem. I'm going to call A 0, 0. I'm going to call B 2, 5. And I'm going to call C 7y. Okay, just because it will be a little bit easier to talk about. All right, so for this problem, right, I need to find AB. I need to find B to C. And I need to find A to C. Okay, so we need our 3 sides. Okay, so if I was looking for A to B, right, 0 to 2 is a distance of 2. 0 to 5 is a distance of 5. So D is the square root of 29. Alright, so if I was looking from B to C, right, so here's where life gets a little tricky, okay, because I don't know one of those distances, okay? So here we're going to get D squared equals, well, 2 to 5, let me switch colors. So 2 to 5, or 2 to 7 is a distance of 5. Right, then we get 5 to y, so that's a distance of y minus 5. Alright, and there's not really much I can do to solve that right now, so I'm just going to leave that because we don't know what y is. Alright, and then A to C, so 0 to 7 is a distance of 7. And 0 to y is a distance of y. Alright, so when we plug this into the Pythagorean theorem, right, we know that we're going to have square root of 29 squared plus whatever this is equals, right, whatever that is. Alright, so let's just plug in some numbers and see what happens here. Alright, so let me plug in, let's just start with 1, right? So if I plugged in 1, right, that would give me, I have 25 plus 1 minus 5 would be negative 4. Negative 4 squared would be 16. 25 and 16 added together would be 41. And then if we plugged in 1 over here, right, so that would be 49 plus 1 would be 50. I did not write my squareds up here, which I need, right, because all this is saying then in the end is I'm going to have 29, right, plus that blue number should equal this pink number, okay, and 29 plus 41 does not equal 50, okay, so I know that it was not 1. Alright, so let's try 2 and see what happens with 2. So if I plugged in 2, 2 minus 5 is negative 3, negative 3 squared is 9, 25 and 9 would give me 34. If I plugged in 2, right, we were on 2, 2 squared would be 4, so I did not switch colors, so 2 squared was 4, 49, and 4 would be 53, while 29 and 34 add to 63, right, so not quite. Alright, so let's keep trying here. So let's go back and let's plug in 3. So if we plugged in 3, right, 3 minus 5 is negative 2. Negative 2 squared is 4. Okay, so that would give me 29. Okay, if I plugged in 3 over here, right, y squared would be 9. 49 and 9 would be 58. So here, if we added 29 and 29, I get 58 equals 58. So the correct answer for this question is y should equal 3. Okay, so definitely a little challenging. You had to play with those numbers a little bit. And I just kind of plugged them in because there were only a couple to try. So a little bit of guess and check work. We probably could have figured it out a little bit easier by looking at those numbers a little closer instead of just plugging each one in. Okay, that is it for your 9.6 notes. So go ahead and log into Big Ideas and try out those problems.